All right, so here we're going to talk about inverse functions. Now, what inverse functions are and what they mean. Inverse means opposite. Inverse functions are functions that undo other functions. Some examples, some opposites, some inverses you might already be familiar with. If you're adding something, the inverse of that would be subtracting it, right? You know that plus 2 would undo minus 2. Same thing for multiplying, dividing. You know that multiplying by 7 would be the opposite of dividing by 7. But here's an example of a function that we'll look at in a second, but these are inverses as well. X squared and square root of x. These are opposites, right? Squaring something is the opposite of square rooting something. They would undo each other as well. Some ordered pairs, some things you might not have thought about. 4, 8 and 8, 4. Those are inverses as well. They are opposites of one another. I'm not talking about negatives here. I'm just talking about what you'll notice is switching x and y, and that will become a theme later on. Now, f of x, that could represent our standard function. The opposite is what we call f inverse of x, but it's denoted like this. It's got f kind of like it's a -1 power of x, but that kind of denotes the inverse function. So f of x is the way to write the original function, and f inverse of x, or with that -1, that's a way we would write or indicate that we're writing the inverse function. So inverses, as I mentioned, x squared and square root of x are opposites. So for instance, if you put 3 into the x squared function, you're going to get 9, right? Because 3 to the second power, 3 squared is 9. But if you take your inverse function, you put 9 in it, it spits out 3. It undoes what that original function did. And we get back to where we started because it's the opposite, right? It's counteracting. It does the inverse. Okay. Now, visually looking at this is important as well. Here are some points. These points have inverses, right? The point 4, 7. Let me kind of use a color here that might stand out a little more. This blue, maybe. 4, 7. Its inverse would be 7, 4. The point -5, 3. The inverse would be 3, -5. Notice you didn't change the negatives. The -5 was still a -5. The 3 was still a +3. But you switched them around. You can do this for a lot of different things. You can do this. Let's try, -2, 4. Its inverse would be 4, -2. Let's try -10, 1. Its inverse would be 1, -10. You can do so much. You can do -7, -3, and the inverse would be -3, -7, which hopefully I can find that properly. Now you might notice that there's sort of a reflection here, but the reflection is not exactly sideways. The reflection is diagonal, right? You can see, and that's a terrible diagonal line, but it's reflecting from one side to the other, right? So inverses will reflect upon that line. And why do they reflect upon that line? Think about it before we might mention it. Think about what that line is. Okay? That line, and here's another example of those points switching, but that line is the line y equals x. And that is the line it's reflecting on because those are all points that are identical, right? 1 equals 1. If you have the point 1, 1, and you try reversing it around, it would still be the point 1, 1. It doesn't change, right? The point 5, 5, if you try flipping it around, it's still going to be the point 5, 5. So it's reflecting upon that identity function, that y equals x line. So make a note, though, of course, of what we have here on the side. If you have the function g of x and it's got these ordered pairs, then its inverse function is going to be the reverse of all these ordered pairs. So it'd be 0, 1 would be now 1, 0. 1, 2 would now be 2, 1. 2, 4 would now be 4, 2. And you see all these are just kind of reversed. 8, 3, 4, 16 is now 16, 4. And of course, if you graph those points, you will see them having that reflection. All right. If you were to sketch an inverse, just try to make a sketch that reflects, like I said, across that diagonal. So you can definitely see the reflection here. And I think if you go back to a couple of notes ago when we talked about our parent function notes, this red line is kind of like the line, y equals, it was our exponential function, so I don't remember how we wrote it. We might have read it as a times b to the x. And this blue function here is the inverse of that. The inverse of an exponential function is a logarithmic function. So this would be y equals log x, or ln of x, something along those lines. Right, those are inverse functions. You can tell that by looking at the graph if you didn't already know it yourself. So, and just take a couple points, for example, the point 0, 1, its inverse is 1, 0. The point 2, 4, its inverse is 4, 2. You can see this is not really, but it's close to negative 4, 0, the inverse being close to 0, negative 4. So everything lines up. Everything's the opposite. All right, so now let's talk about writing the equation of an inverse function, right? If I'm given this equation, how do I know what the equation is of the inverse of it? And it stems off of what we just talked about with the ordered pairs, for example. Remember the ordered pair 4, 8? Its inverse was 8, 4. That's a clue as to what you're going to do here. And if you haven't figured it out, the clue is that we're switching x and y, right? X and y switch. So to get us started on writing this inverse, what we're going to do is write the same equation, but we're going to switch the x with the y. We're not going to move anything else. We're not going to move any of the numbers. We're just going to put x where y is, and we're going to put y where x is. Okay, it's the same equation, but the variables have switched, and that's all that's switched. Remember, nothing goes with those variables. It's literally just them rotating. Now, we've got our problem started. The only thing to do is finish this equation, get the y by itself so we know what the function is for our inverse. Okay, so solve this function for y. So to get this y by itself, we'll have to add 12 to both sides. So that's going to leave me with x plus 12 equal to 6y, and then we'll divide by 6 all the way across. So this would be x over 6, which might also be 1 over 6, x plus 12 divided by 6, which is 2, equals to y. So there's your inverse function. If the original function was 6x minus 12, the inverse function is 1 over 6x plus 2. Now, I'll give you some advice. Don't ever try to eyeball the inverse. Don't ever just try to take a guess and think, oh, well, that looks opposite, so that's probably the inverse, without actually working it out. It's not going to be very easy to eyeball what the inverse is. So you do have to work it out. So remember, there's kind of just two steps to this process. Step number 1, switch the x and y. Step number 2, solve for y. Okay? If you want to write that down, write that down. Switch x and y, and then solve for y. Okay? You could look at the graph. So here's an example, just kind of looking at a graph. I kind of think we skipped this in class, but just to give you an illustration. So this line, 3x minus 6, that would be the line that kind of looks like this, if I'm getting it right. Something along those lines. The important thing is, though, that we're going to write the inverse of this function. So remember, step 1 is switch the x and y. So this equation would be x equals 3y minus 6. And then step 2 is solve for y. So we'll begin by adding 6 to both sides. That leaves us x plus 6 equals 3y, and then we'll divide by 3. Those don't look like 3's, but it's okay. This is going to be 1/3 x, because 1 over 3x plus 2 equals y. So if we try to graph that, that would be, let's do this one in red. A y-intercept at 2, and a slope of up 1 over 3, up 1 over 3, up 1 over 3, kind of like this. And hopefully, we'll see that all those points are completely opposite of the points we drew originally, right? You see that this point is the point -6, 0. Well, you'll notice over here we have the point 0, -6. Remember the inverse? This point here is the point -3, 1. And the original line had a point at 1, -3. This one was at 0, 2. And 2, 0. Of course, you can see that one's the same thing. It's 3, 3. So flipping 3, 3 is the same as 3, 3. All those points are opposites. So, and you can kind of, again, see that it's mirrored from one side to the other. Right? It's reflecting, it's like rotating that thing, rotisserie style, 180 degrees. And you have your inverse. So let's try maybe 1 or 2 more of the equation ones. Well, I'll go ahead and just kind of skip this one for the video just to keep it short. It's very similar to the ones we previously solved, so I'll just kind of show you. Remember, you switch your x and y, so that would be your equation, and when you solve for y, you'd add 2, then you would divide by 4. So you get your equation there. Notice it's simplified 2/4 to 1/2, same old thing, okay? This one, remember switching your x and y would be your first step, then solve for y, so that would mean subtracting 8, and then multiplying by 5. When you multiply this side by 5, just be careful, you are multiplying both of these things by 5, so you're going to have 5x and you're going to have 40. You're multiplying both terms by 5. But now I want to try it with a different type of equation. I want to try it with the quadratic equation. Okay, so we have our quadratic equation, y equals 3x squared plus 2. Remember, there's only 2 steps here, okay? Step 1 is switch x and y. So this now becomes x equals 3y squared plus 2. And now second step is solve for y. So we got a handful of things to do. But remember, you're kind of focused, if you don't remember, on doing the PEMDAS backwards. Whenever you're solving equations, you solve this PEMDAS backwards. So we're going to focus on trying to find anything that's subtracting or adding, which is this 2. So we're going to deal with that first, right? That'll take care of this side of PEMDAS, and then we'll work our way to the left. So that's going to get rid of that. We have x minus 2 equals 3y squared. Now I'm looking for anything that's being multiplied or divided. So I'm multiplying by 3. So we'll take care of that. Next, we'll divide by 3. Now this is tricky. You're dividing x minus 2 by 3. Now, you could do it like I've done it here, right? Where you just say, hey, I'm taking x minus 2 and dividing it by 3. That is fine. You might have also written it as x divided by 3 minus 2 divided by 3. This or this, it's the same thing. It's not going to make a difference. But the reason I chose to do it the way I've done it is it looks a little bit less complicated. I'm not trying to solve and get a number here. I'm just trying to move things from one side to the other. And because there's still one more step in this process, the cleaner it looks, the better it is for me. So it's not wrong if you have it the other way, but just to keep the equation looking cleaner, I'm going to stick with this. So now I'm looking at exponent. Do I have any exponents to get rid of? And I do, right? I have something squared. I have y squared. So how do I get rid of something squared? What's the opposite of squaring something? And the answer should be square rooting it, right? If you square root something that's squared, that's an inverse. That cancels out that squared. But of course, you do it to both sides like you've done in the past. So we have the square root of x minus 2 divided by 3. All right, so all you did was move things over. You moved the 2 over, you moved the 3 over, and you moved the squared over, which ultimately became a square root. So everything's been shifted over. And you've got your final equation. All right, a little bit tricky, but it's not overly complicated. It's just kind of one more step than we're used to, that square root part. But it's something I think you guys can handle. Now, I just want to sketch the inverse. So again, this is just practice on the sketching pad. Remember, if you're trying to mirror it on this side. So that reflected downwards, let's see, it's at 2. So it'd probably be about here. So it probably looks something like this. Now, the only issue with this is only half of it matters. Remember, this is not a function here because it fails the vertical line test. So what we're going to do is erase this bottom part so that it becomes a function and now pass the vertical line test. And you might think, and that's a very terrible sketch. Let me fix it just a little bit. Oops, not a highlighter. Just erase it, and let me try it one more time. Something kind of like, again, I'm using the highlighter. Like this, I suppose. Remember square root functions, if you go back to your parent function notes that we took a couple days ago, you'll notice square root functions look like that. And again, they have to look like that because you can't have two values at one point for square root functions. So there's not going to be a point here and there because then it wouldn't be a function. All right, so all it is it really just looks like that, but you can see it's still reflecting this part of the graph. But yes, they are a little bit tricky, those quadratics. All right, and the last example we'll end on is this one. Remember, you can write this as y equals instead of f of x equals. But remember, step 1 is to switch x and y. So you can see I've already switched x and y. Now I'm just going to try and solve for x. Now this is a little bit tricky. You know, when you think of the PEMDAS, that's helpful. However, you have to pay attention to the fact that the -5 is inside the radical. You cannot move anything or touch anything inside the radical until the radical is gone. If the -5 was out here, then yes, we would move it first. But since it's buried inside the radical, we have to get rid of the radical first. So notice we have the square root. Well, what's the opposite of a square root? The opposite of a square root is squaring. So if we square both sides, that's simply going to remove my square root sign. So now it's going to be y minus 5. And it equals x squared. So now there's no radical. Now I can move the 5, and I'll add that 5 to both sides, and I'll be done. I'll have y by itself. Y will equal x squared plus 5. All right. That's going to do it. I'll go ahead and show you. There's a graph here again for you to practice a sketch on. So there's your square root function. The inverse would be something like this, but remember it's going to be a quadratic, so it's kind of on both sides. All right. So there you go. I'll leave it there. I'll see you guys in the next one later.